Today we're going to look at proportion word problems. So first off, a proportion is an equation stating that two ratios are equal. So for example, 2 over 4 is equal to 3 over 6. Or 15 over 5 is equal to 3 over 1. So this ratio is equivalent to that ratio. This ratio is equivalent to the other one. So when we want to determine whether two ratios form a proportion, so we have these things that we call the cross products. Okay, so that's when you're looking at your two diagonals. So the 5 and 24 are a set of cross products, and the 4 and 30 are a set of cross products. So they're kind of the diagonals. And the cross products of any proportion are equal. So if it is in a proportion, those cross products are equal. So in this example, if you have the proportion A over B equals C over D, the product of these diagonals should be equal. So A times D should be equal to C times B. So if we look at it for this problem, 4 times 30 should equal 5 times 24. Well, 4 times 30 is 120, and 5 times 24 is 120. So we can use this idea that if the cross products are, or if they form a proportion, the cross products are equal. We can use this to solve for unknowns. Okay, so let's look at this first example. 2 didn't print, so we're not going to worry about that. 3 and 2/10 over 4 equals 2.6 over n. So sometimes it's easy to see what you need to do, multiply or divide. But when you've got decimals, it's not always easy like that. So that's when we're going to multiply our cross products. So you look at the diagonal that doesn't have the variable in it. So the 2.6 and 4, and we multiply those. 4 times 2.6, which equals 10 and 4/10. Okay, and then we divide by the number that's in the same diagonal as the variable. So you divide by 3.2, and we get that n is equal to 3.245, or about 3 3/10. So now let's apply this to word problems. So number 3, a 12-ounce bottle of shampoo lasts Enrique 16 weeks. How long would you expect an 18-ounce bottle of the same brand to last him? So we're comparing ounces to weeks. So I'm setting up a proportion. Anytime I'm comparing two units, I can set up a proportion. And I'm just labeling it so I don't mess up. So the first scenario says that 12 ounces last 16 weeks. The other number that we're given is referring to ounces, so we are solving for weeks. So we look at our proportion, we multiply the two numbers that are diagonal from each other that don't have the variable in it. 16 times 18 equals 288. And then we divide by the number in the same diagonal as the variable. So divide by 12, and we get 24. What were we solving for? Weeks. Number 2. About 13 out of 20 homes have a personal computer. On a street with 55 homes, how many would you expect to have a personal computer? So we're comparing those that have computers to the total number of homes. So 13 have computers out of 20 total homes. The other number that's given to us is talking about a total amount. We are solving for how many would have the computer. So we multiply the two numbers that are in the diagonal with each other without a variable. So 13 times 55, which equals 715, divided by the number that's in the same diagonal as the variable, and we get 35.75, if you want to round, 35.8 homes with computers. Number 5. In a bag of red and green sweets, the ratio of red sweets to green sweets is 3 to 4. So 3 is referring to 3 red to 4 green. So this one's slightly different, so you got to be careful with how you're setting up the proportion. If the bag contains 1,050 total sweets, how many red sweets are there? So our proportion, we're not actually comparing red to green, we're comparing red to the total. So we're not actually going to use that original ratio of 3 to 4. We're using the 3 because the 3 is referring to how many red, but the total is, well, if there's 3 red and 4 green, that gives us a total of 7. Now we look at our other number of 1,050, which was referring to the total. We are solving for how many red. So we multiply the two numbers that are diagonal from each other. So 3 times 1,050, which gives us 3,150. And we divide that by the number in the same diagonal as the variable. And we get 450 reds. All right, last one is looking with fractions. It's the same setup. You're just dealing with fractions. Brian irons 2/9 of a shirt in 3 3/5 minutes. How much of a shirt does he iron per minute? So we're looking at the shirt to minutes. So 2/9 of the shirt are ironed in 3 3/5 minutes. We want to know how much per minute, which is referring to 1 minute. So if we look at this, the two numbers that we'd multiply is 2/9 times 1, which is just 2/9. And then we're dividing by the number in the same operation, or same diagonal as the variable. So divided by 3 3/5. So now we've got a fraction that we've got to deal with. So first, I'm going to make it improper. 3 times 5 is 15, plus 3 is 18 over 5. Then we keep it, switch it, flip it. Simplify 2 and 18, divide by 2, multiply across, 5 over 81. And that's how you do it.